Hello all, and welcome to this breakout session on drawing health management with BricsCAD V24. My name is Wouter Nys, and I am leading the AI team at Bricsys. In this session, I'll showcase you the next iteration of the drawing health command that is available in all license levels of BricsCAD and enables you to clean up your drawing data even more thoroughly whenever you want to do it in your design workflow. For those unfamiliar with BricsCAD, or at least with drawing health, BricsCAD features a unique set of drawing optimization tools. Some of them are familiar and quite old already, such as the purge command and the audit tool. Others are more recent and leverage the power of artificial intelligence, such as Blockify. To make it easier to access these various optimization tools, or at least to avoid you having to know their purposes all by heart, we've introduced a new drawing health tool last year that groups together a lot of these drawing optimization tools in a single, powerful, and easy-to-use command. Based on positive feedback from our users, we've continued the development of this tool, for example, by adding a new task that corresponds to the overkill command, or by enhancing the routine management to allow multi-import and export, and also by making the result panels more interactive. Now, I'll walk you through 3 examples, use cases from completely different industries, where applying drawing health yields some tremendous advantages. So, it's time to dive in and see how drawing health performs in action. This tool can be launched from many places in the BricsCAD user interface, such as the command line. However, for this demo, I'll focus mostly on the ribbon. In the Manage tab of the ribbon, we can see this panel of drawing optimization tools. The most important one can be found here, directly up front. Launching drawing health, the experienced V23 user will directly notice that we've revamped the user interface a bit. The new drawing health tasks now contain the name of the individual drawing optimization tool it corresponds to. And also, the creation of routines and management of routines has been simplified. For example, with the Edit button, we can tweak some of the out-of-the-box routines. Or, with the Manage Routine button and the Routine Manager, we can simply edit an existing routine, rename it, duplicate, for example, to make some tweaks, export it to share it with some colleagues, and finally also delete it. Finally, here at the bottom of the command panel, with the switch, you can decide whether you want drawing health to run fully automatically, or you still prefer to have some interactions to achieve your result. Let's now look at this first use case. Suppose I'm working in a terrain surveying company, and I've obtained this drawing from one of my colleagues. Before doing any editing work, I want to assess and improve the quality of this drawing. First of all, with the structure browser, we can see that this drawing contains thousands of entities on different layers. And also, when looking more detailed, we can also see here at the left, for example, this complex polyline. Looking at the Properties panel, we see that it contains more than 16,000 vertices. It quickly becomes clear that this drawing is a perfect candidate to apply some optimizations to, making it more lightweight. Let's try it out. In this case, I will set up a routine from scratch. This is a 2D use case, so I'll pick some relevant optimization tools for 2D. For example, I would like to purge unused entities in this drawing. Also, I want to detect and fix potential errors in the database with Audit. With the Find Outliers task, I want to identify faraway objects and move them to more decent coordinates. Further, I'd like to simplify 2D geometry by removing redundant vertices and high-density polylines. Finally, I would like to reduce any repetition possible. With the new Overkill task, I will look for duplicate geometry. And the final task I will add now here is to look for duplicate block definitions in the database, This means that multiple definitions contain duplicate geometry. So, this is how I want my routine to look like. Now, let's have a look in detail at the settings of, for example, the simplified task. As said, this task will analyze overly complex polylines and try to remove some vertices from it to make it more lightweight, without changing the general shape of the polyline. We choose the Reduce Vertices option in the distance mode. For the maximum angle, we choose a value of 2 degrees, and for the maximum distance, we choose 1 meter. This means that if one vertex is within a distance of 1 meter of the two adjacent vertices with an angular change that is less than 2 degrees, that vertex will be removed. For the duplicate geometry and duplicate block tasks, the experienced BricsCAD user will recognize the same settings and options as with the standalone overkill command. Now we can save this routine to reuse it later, or we can simply try it out, which means that we can go ahead quicker and use it without saving it. Now, in the command panel, all the tasks we selected are nicely listed. So let's now inspect the health of this drawing. Firstly, the purge task has identified quite some unused objects. It found 6 unused block definitions. This means that there are no block references in the drawing that point to these definitions. Also, it seems that there are some unused text styles. In general, the logic in drawing health is that if you click the next button, basically you will apply all the selected optimizations. In this case, we will purge all these unused items. Next up is the audit task. And happily, it seems that there are no database errors in this drawing. The Find Outliers functionality will quickly show us that the valid region, basically this green box over here, is located very far away, or better, the entire drawing geometry is located at very far away coordinates from the valid region. Of course, this could have good reason, so it's not necessarily bad. But in this case, we don't like it. For example, we can have a look at this biggest cluster, which is the main drawing. In this case, we will just select all the entities and choose to move them to the valid region. By zooming out, we quickly see that with one click of a button, all the geometry is nicely located at the origin. Moving forward, the simplified task has identified more than 50 polylines that can be readed. Using the zoom functionality, we quickly identify this polyline we looked into at the beginning of this demo. We'll now simplify all 51 polylines. The next task is the new to V24 overkill duplicate geometry task. We're presented with a long list of duplicate entities. And again, using the zoom functionality or by simply double-clicking, we can easily find overlapping objects. But overkill doesn't only find overlapping objects, it also finds partially overlapping entities. For example, in this case, it identifies 2 aligned collinear lines, so basically these 2 lines, which can be joined together. So, finally, the overkill task for duplicate blocks has identified 5 duplicate block definitions. So this means that there are 2, in this case 2 block definitions containing the same geometry. Using the drop-down, we can choose which definition to keep and which one to remove. And we can base ourselves on the number of references to each of the definitions in this drawing. So, that's it. In this final page of the command panel, we're presented with an overview of all optimizations we've done on this drawing. So we've purged 10 items, 6 blocks and 4 textiles. Apparently we've moved over 14,000 outliers to the valid region origin. We've simplified 51 polylines and we've removed a lot of duplicates. So with this checkbox here at the bottom, we can choose to save the report for future reference. Let's now switch to a second use case from a completely different industry, the music event world. This 3D model consists of 350 solids and some other objects. When looking around, it quickly becomes clear that this model is made up to quite a high level of detail. Looking in the File Explorer, we can see that this model consists of 93 megabytes. So this seems like a valid candidate to apply Drawing Health on. Let's see what Drawing Health can do over here. As usual, we'll start with setting up a useful routine. Since we're working with a 3D model, we'll pick some tasks which are useful for a 3D use case. As in the previous task, we'll again go for the purge command to look for unused objects. Also, we want to look for errors in the database. Next, with the DM audit task, we will actually check for problems in the 3D ACES-based geometry. Again, we pick both of the overkill tasks to identify both duplicate geometry and duplicate blocks. And finally, we select tasks from the Blockify command. We want Drawing Health to identify geometry in model space which matches geometry from existing block definitions. Finally, we want Blockify Drawing Health to identify groups of equal solids which can be replaced by blocks. And again, we can use the routine editor to quickly change some settings and options. In this case, we will save the routine in order to be able to reuse it later. We will call it 3D cleanup. Let's go. Firstly, the purge task has found quite a lot of unused entities. 17 blocks, 7 layers, some line types, some dimension styles, and so on. By clicking Next, Drawing Health removes all of them. The audit tool will look for errors in the database, but happily, in this case, the database seems to be in the proper state. The next tool is DM Audit. It will analyze in detail all 3D geometry and look for geometric errors in the 3D solids. This is a quite resource-intensive calculation, but after a few seconds, we can inspect the results. DM Audit has identified 12 problems in the current model space. Using the zoom function, we can look in detail what's going wrong. For example, here, we can look into this curtain-like surface. It's not G2. This means that in some parameter values of the surface, the second derivative of the surface will not be continuous. This might pose problems for certain modeling operations further downstream. And similarly, some curves underlying the edges of the solid are not C1, which means that there's a knot. Or in more mathematical terms, the tangent vector along this curve is not continuous. By toggling all these checkboxes on and clicking Next, DM Audit will try and fix these issues. Next up is the overkill duplicate geometry task. Quite a lot of duplicate polylines and 3D solids can be identified. For example, using the zoom function, we can see that some parts of these loudspeakers are duplicate. Or here, for example, we have some polylines which are overlapping. Apart from removing duplicate entities, overkill will also allow us to do some optimizations. For example, in this case, apparently this line is not one line, but a combination of 4 collinear lines. In this case, it will merge them together. Again, by clicking the Next button, all of these selected optimizations will be performed. Finally, Blockify will look for groups of similar 3D solids. Using the list view and the zoom functionality, we can easily get an idea of which objects are duplicates. For example, here, we can see that these supporting structures of the main event stage are two duplicates. And also, maybe more interestingly, we can find here 24 matching objects for the loudspeakers. It can easily be replaced. By clicking Next, all of these solids will be replaced by block references to 35 new block definitions. This will take a while, because a lot of new objects need to be created. But in the end, you will be able to inspect a nice report again. Here we can see again all the issues we addressed. We indeed find back the 16 geometrical errors fixed by DM audit, and also the 35 groups of equal solids replaced by block references to new block definitions. Now, let's save this file on disk. So we save it as a cleaned up version. Again, we have a look in the File Explorer, where here we can see that we basically reduced the file size by a factor of 7 to only 13 megabytes, just with a few clicks. This is important because it will have a huge positive impact on the performance of this file. It will load quicker, will be more lightweight in manipulations, and so on. Before we wrap up, as a final case in point, let's have a look at this use case from the construction industry. This file contains over 2000 3D solids, and as you can see, it represents a quite large model of a structural bridge. Let's see what Drawing Health can achieve on this model. Since we're again dealing with pure 3D geometry, we can reuse the same 3D cleanup routine as last time. Let's go. With Purge, we can clean up unused layers, detail view styles, and dimension styles in just a single click. Next, the audit task is looking for errors in database. But again, it seems that we have no issues. Next up, the DM audit tool is currently analyzing for 3D geometrical errors in the model. As you can imagine, it has a busy job. There are quite some objects in this model. And indeed, we can see there are quite some issues with the geometry in this model. For example, here, some of them are related to these elongated structural solids. But others are involving vertices which are not lying on the face surfaces. These type of issues can easily sneak in when importing 3D geometry from other file types. Happily, with Drawing Health, they can be cleaned up with one click of the button. Next, the overkill task has identified two sets of duplicate 3D solids. Here, for example, at the end of the bridge, and also solids which are spanning the entire bridge. Just clicking on the next button, the duplicate solids are removed. Finally, the Blockify match equal solids task will loop over all the repeated 3D geometry. The results are quite impressive. It has identified 116 groups of equal solids. Or let's have a look at this component. Basically, this has a connection between the handrails. It occurs 46 times in this model. Let's replace all of these with block references to new block definitions. And in doing so, we again come at the end at the report panel, where we see what has been going on. So, this brings me to the end of this demo. We've covered 3 use cases, from a surveying use case, over an event stage design example, to a model of a huge bridge. No matter what industry you're in, whether you're working with 2D or 3D, or a combination of both, whether all your design data is created in-house, or you typically import existing drawings to start from, we're convinced that drawing health might save you tons of disk space, loading, and manipulation times. Thanks for watching!